RV owners can tackle many of their RV issues if they have the right tools, and a multimeter is the most essential. And I've noticed many people become intimidated when they first start using one. So in this video, I'll simplify the process by covering the basics of the multimeter, explaining the most common features, and show you how to trace power to identify what's broken. My goal is to help you build skills and confidence so you feel prepared to tackle troubleshooting at your own pace. Now there's many multimeters you can choose from. The Klein CL800 is the one I use every day for doing tech work. I also have an older Greenlee meter. This thing is over 20 years old, but it still does the same job. Actually, during some of the troubleshooting, I'll use this one because it's simpler to see where the settings are at on the dials. So these both work the exact same way. You can also get some of those budget meters. I've seen some for around $20. If you're just doing basic DIY RV work, those will work just fine. But if you're doing advanced work, you'd want something like this. And you can find everything I'm talking about linked in the description of this video, except for this guy, because it's too old to link it. Okay, we need to go through a safety briefing. And we should be familiar with electricity, knowing that it's dangerous and touching the wrong stuff can kill you. I'll point out some hazards that I can help you with along the way of don't touch this, don't touch that. But what I don't know is in your situation, some that could be wired improperly. There could be hazards that are in your situation but not in mine. So if you're unsure, always call a professional. If you are working your way through it, make sure you go with your own skill level and stay safe. And now we're to the fun part. Let's go through the multimeter, show you how the dials work, what the symbols mean, and how to use one of these guys. Okay, trying to find the best way to show you, and I think this setup will work. So I'm going to go through settings on the Greenlee because it's easier to see the symbols. Then we'll go through the Klein because some of the people watching this are techs and you're using this actual meter. So start off with, your meter should be in the off position. And how this works, this dial can change our settings. This screen shows us our readings, and the buttons down here we'll get to later. So we go from off to V. V is for volts, and AC voltage is a squiggly line. Actually a sine wave signal. Now we went to volts AC. If you look closer on the screen, you can see AC in that same little symbol. You will see some volts floating around here. That's pretty normal. And this is right at the 1 volt range. Don't worry about that. You'll get a proper reading when you start using it. So now let's go to volts DC. So the other V, and DC symbol is that straight line with the 3 dots underneath of it. And you'll see that same symbol here on the screen. And the same thing, you might see it floating a little bit, a couple volts that pop in there. You don't see that as much with DC volts as you do with the AC voltage. So I'm going to go from volts to amps. Amps is all of our A's. So amps AC be the A with a squiggly line. And we have 2 different DC settings. Either one of these will work the same for RV work. So let's go up here to amps AC. You can see now we have AC squiggly line here on the screen. Let's go up to DC. And you can see the 600 versus 400 read the exact same thing. The other functions we're going to use during this portion of the video will be continuity and resistance. So that is this symbol. That little horseshoe looking symbol, that's your resistance symbol for ohms. This sideways Wi-Fi symbol, that's for continuity. So we go to that one. We would leave this dial in that same position whether we're checking for continuity or ohms. The other function, when we're on amps, let me back up here a second. So go to amps AC. To check amps with this meter, that's what the clamp does on the top. So you can open this up by pushing the button, and you would put this around a wire. So let me grab one of these wires, for example. So if this wire was our wire we're going to use to check for amps, we'd open it up, put it around it, and then see if we have a reading on the screen. Now where these leads go into is right down here in the bottom. So there's going to be a red lead and a black lead. So take the little angle part of the lead, it just pushes into this little slot, just like that. Grab the black lead, goes into the black side, pops in. Now we're ready to use this meter with our test leads. We can go to work. Now let's set up the Klein meter. So this works pretty much the exact same way as a green lead did, but except we're going to have our dial functions, be our volts, our amps, our continuity is all in this section. The parts above the continuity section will be advanced features on this meter. So we'll start off in the off position. We'll go to V for volts, and you can see there's only one V symbol on this Klein CL800 meter. And the white symbol is the default setting. What default setting means is when we go from off to that position, it goes to that default setting right away. And you can see that on the screen. Down here on the left hand side is that squiggly line symbol for AC voltage. Now on this one, if we want to go from AC to DC voltage, you can see, I'll bring it a little bit closer here. Our little DC symbol, that straight line with 3 dots, is underneath of the white AC symbol line, and it's orange. We will use the orange select button to change between the AC volts and DC volts. So hit that. And what you're going to see is right here, it's going to change from that squiggly line to that straight line. See that? Now we're in DC voltage. So let's do the same thing with AC voltage. But watch this symbol right here. It's going to change from DC to AC. So we're on A for amps. That DC symbol went away, and now we're on AC amps. That's because our squiggly line up here is white, so it goes to the default setting first when you move the dial to that desired function. So we moved it from volts to amps. We went automatically to AC amperage. Now if we want to go to DC amperage, the same way as voltage, we will push that orange button. We will switch from AC to DC. You can see here on the screen. Now with these meters, it's pretty common when you go to DC voltage, it's going to read some numbers on the screen. That's just how these meters work. You will want to zero this out before you start using this for DC amperage. So we will push and hold the orange button, which is also the 0 button, and it will start at 0. Now we're ready to work with DC amperage. Next up, let's go to our continuity. So we move the dial up here to that sidewise Wi-Fi symbol. You see that one is white. I'll bring it closer here. That's your horseshoe omega symbol for ohms. And this one I'm not going to use. I'm not even going to explain it to not confuse you. So we went up here to continuity, and by default it's on the white setting. So we are on continuity setting of this meter. If we want to test resistance, you'll want to hit the orange button. You can see right here on the screen that horseshoe symbol showed up, and this one automatically selects which mode it'll go to. When we test this later, I'll show you more on using this function. In this one, our test leads go into the bottom. So we have a red and a black. They plug in just like the green lead does, except they're in the bottom versus the face of the meter. And also like the green lead, this one has an amp clamp on the top. You pop that open, put it around your wire, and you can go to work. One nice benefit of this one, this little guy here on the side, you can take your test lead and hold it in there, so that way you can free up a hand. So now you have red lead on the meter, black lead in your hand, and you can hold it without having to find a third person. Alright, are you ready to test some AC voltage? Before we get there, let me explain what voltage is. Voltage is a difference in potential. So, if we take our meter, let's say we're testing something, we have to put the red and the black leads on 2 different items to read the difference between those 2 wires. If we put them on the same thing or touch them together, we will get a 0. So, pretty simple to explain it, but let me show you. That way you can understand using the meter. And we'll use both the green lead and then the Klein. Okay, we're down here at an outlet, so we're going to test the voltage at this outlet. And I'm sure we're all familiar with outlets. There is 2 spots you can plug into, top, bottom, right and left, however you want to call it. And on the outlet, you're going to see one slot's going to be smaller than the other one. Your smaller slot should be your hot lead, and the bigger slot is your neutral, and then the round one is your ground. So when we are testing, I'll show you how you get the voltage in there. So we're going to take our meter, put it to volts AC, that's V and squiggly line. This is where the third hand comes in occasionally, but we can make it work for you. Now we'll take our red lead and hot side. That's a standard practice. On AC volts, you can put red in either side and you'll get the same reading. But for simplicity terms, put red into the hot side. We'll hold that with our finger. Remember, don't touch the metal tip part because this is now live electricity that we're touching. Keep your fingers behind that little shelf part there. And we'll put the black lead into the big slot. And in outlets, you will have to move them around a little bit so you touch the metal inside. Look on your meter. We are reading 120.6 volts. Oh, I lost connection a little bit. So 120.6. That's from the small slot to the big slot. That's hot to neutral. Now we should get that same reading by leaving our red lead in the hot slot and putting our black lead inside of that round hole for our ground. Again, make sure you move them around a little bit. We read 121.9. So we have proper voltage at this plug. The other thing you can check is to go between your neutral and your ground. So we'll take the red lead, put it into neutral. We'll take our black lead into our ground. This should read 0 or pretty close to 0. You can see we're reading 1.4. So that means there's no power between neutral and ground, which is good. You do not want power between neutral and ground. You should only have power on your hot side. Now, choose a Klein. So our leads are in. Also remember, it's always a good tip, make sure leads are tight. If these become loose at the bottom, you might not get a reading or get a false reading. So always make sure these are tight before you're checking voltages with your leads. We'll take the dial, turn it to the V squiggly line for AC volts. So we're ready to go. And this is where this little holder comes in handy. Look at that, I got a third hand. I'm going to change position here so I can show you on the camera. So we're going the same way. We're putting the red into the hot lead. And we'll take our black, find where we feel like we're touching something. We're reading 120.9, the same as a green lead. I'm going to leave that black, I'm going to leave the red on the side of the hot down there. Take the black, move it over to our ground. We're reading 122.1. In the same way, we'll take our red. This time we'll put the red into the ground. And we'll take our black, put it into our neutral. We're reading 1.3. So that's the same as using on the green lead. So again, plugs wired properly, different meter, same results. You do see here on the Klein, you have more decimal points. If you don't want to see all decimal points, you can always hit the range button. It'll move a decimal point over. Now this would be just like on the green lead here. You can see you have like 0.1, 0.1. If you don't want decimal points, you can just move it over. RV is always fun to record in small spaces. We got the big light bar, so we can see what we're doing. So let's check some DC voltage now. And DC voltage works the same way as AC voltage. You're checking difference in potential between your two test leads. One difference with DC voltage is you will see your polarity change on your meter screen. I'll show you what that means. But that's why I said during the AC part, it's good practice to keep your red lead on the hot side and your black lead on your neutral side or your ground side. On DC voltage, we're going to call our red lead to our positive and our black lead to our negative. So it changes terminology a little bit, but you're still checking things the exact same way. So whether if you have a lead switched around, red or black, you will get the same reading, but you'll see the negative sign show up on the meter. And we're going to pause for a second, and let me show you what a test light is. Some people use these for diagnostics, and you can get some false diagnostics with these. All this is basically telling you on DC voltage is if there's some power there or not. You don't know how much or how little power is at that point. So I'm going to show you how to use this. So we come down here to the breaker box. I already removed the cover, And let me give you a quick little overview of the breaker box. This side here with all of your breakers, this is your AC voltage side, and this little divider that divides our AC on the left to DC on the right. We'll explain this a little bit more later, so let's work with the DC side now. So I'm touching this, and DC voltage is only 12 volts. There's not a danger in this situation. And our negative side is our black wire and or the white wire. Our positive side in here are our red wires. So how this operates is your positive side comes in here and goes down through our fuses, goes over here to our wires, going out to our lights, appliances, or whatever is running out 12 volts inside of the RV. So let's take our little alligator clip on a test light. We'll put it up here on our negative. Now we'll take our test light and we'll touch it here in the positive. You can see we have a light. And we don't know how much voltage is there, but we can tell there is voltage. If I took this test light and put it over here to our ground we're hooked up to, we get no light because we're hooked up to the same point. So now let's use our meter and show you how to check actual voltage at these points. So we've got our green lead meter. We were on AC voltage last. Then we need to go to DC voltage. We'll turn the dial to our V DC symbol, the straight line with the 3 dots. Now we're on DC volts with this meter. I'll set that down so you can see it. When we're testing around this fuse panel breaker box, we will take our black lead, touch it onto our negative side, and a red lead we can check any point around here we want to see how voltage is flowing. So I'll start up here on our wire coming in, down here on the meter. You can see we're at 13.5 volts. Let me prop this up maybe like that. So we have 13.5 volts coming in. If we go down here through our fuses, this side should read the same, 13.5. Now if we go to the right side of our fuse, that's our power coming out of our fuse. What's our meter say? 13.5. Now as you can see on this fuse, if you zoom in a little bit, there's 2 little metal tabs. So we have a little metal tab here. So that's one side of the fuse. Metal tab over here, that's the other side of the fuse. Power goes in the fuse and out over here. Then power comes over here to our terminals where the wires are connected. So that's the flow of the power through here. So the first side I checked is on the left-hand side. So 13.5. That's the exact same as a red wire coming in up here at the top. If we go to the right side of our fuse, touch the little metal tab, and the power coming out of the fuse is 13.5. So that's the same. So that means our fuse is reading good. Now if we come over here to our screw where a wire is connected, now let's look back at our meter. We're at 13.5. So in this situation, we have even voltage all the way through from our red wire coming in, down here, into our fuse, out of our fuse, and out to the wire throughout the RV. So that is showing no loose connections, no bad fuses. Everything looks good at this point. So now with our climb meter, we were on AC volts last. Let's go to DC volts by hitting our orange select button. Now we're on DC voltage. You can see the symbol here on the screen, and our current reading is right at 0 voltage. Now we'll have the same operation. We'll hold our black lead on our negative side, and we can check around with our positive. So we can check our power coming in, and look down at the meter. It shows 13.55 volts, and it's the same. You just have one more decimal point. So as you're checking this, you can go through and check all of your fuses if you want to, but typically what I would do when I'm checking an RV is I'm isolating it down to that circuit. So if you looked at your fuse panel box, it'll have writing on it. It'll tell you what all these wires are for, and you can correlate it to those fuses. So if we went down here, let's say it said this one right here was for the furnace, and we're coming into the furnace here on one side and out there, and we're checking our voltage here at our supply for our furnace. This should match up to the voltage you see on the furnace itself. It wouldn't do us any good if this was our furnace fuse to check these ones down here, because these are for something else. So we want to isolate down to what we're exactly working on. So I would only check one fuse at that point. If you had some misreadings, you weren't quite sure, Then at that point, you can check some other fuses just to see, is it just this one? Is it something else? And you can do some further diagnostics that way. But to keep it simple, you would just check power coming in, through the fuse, out to that appliance or lights or whatever else is running off this side. So now to recap all of that, we would take our black lead, touch it up here to where the black or the white are. That's our negative on DC power. And we touch our red lead to our red side. That's our positive in DC power. If we look at the meter right now, we're showing 13.5 volts. Now let's come back up here to the leads. Now if I was to switch these, put the red on the negative side and the black on the positive side, you'll see on the meter, it still shows 13.5 volts. But right there, underneath of that DC symbol sign, there's a negative. So keep the camera right there. I'm going to switch this back so you can see right now we're on negative polarity. If I put it back, red with red, black with black, that negative sign went away. So that's a sign if you're reading something throughout the RV and you're pretty sure you have your test leads on the right spot, you have black on negative, red on positive, but your meter shows you negative on there, that means some wiring and possibly a switch throughout the RV that you would want to backtrack and get that fixed before going forward. Now we're on to AC amperage. So what amperage is measuring the work being done through that wire. As I mentioned in the beginning, I was going over the meter, how an amp clamp works. You will put the amp clamp around the wire. So that's going to be this guy. So we'd put it around the wire. That's my finger here. Now, let's say there's voltage going through that wire, but nothing is happening on the other end. For instance, we're going to have the wire going to the microwave, to that outlet, and the microwave is turned on, but the microwave isn't cooking anything, so it's not going to be drawing a lot of amps. So let's find that breaker for the microwave, and we'll do a little bit more overview on the breaker box. So this is a 50 amp breaker box. In the center, we have a 50 amp breaker, and from here, we have a 120 volt side to the left and a 120 volt side to the right. If we were to measure voltage here at 50 amp breaker, we would read 240 volts. And the other side of the breaker box, down here, our white wires are on our bus bar. Bus bar is one of these little metal bars, a whole bunch of wires connected to it. So the white wires are our neutral side. And back behind that, another bus bar with all of our bare copper wires onto it. That's our ground bus bar. So we're going to be trying to find the breaker for a microwave. And here in the center is that big 50 amp breaker. Microwave is over here. So this will be the 1, 2, 3. So third one over our 50 amp. So we'll have 1, 2, 3. So this 20 amp breaker right here is for the microwave. Now what we would do is, kind of peek your head down there a little bit. What we can see down from that, this wire right here is going to the third wire, or the third breaker, I should call it. That's our hot going to that. And I did a little bit of tracing already, and I have found that this wire right here is also neutral going to that microwave. So now to test it, we will take our meter, and we're in opposition. We need to go to amps AC. So A for amps, squiggly line for AC. Now we're ready to test. And we see a little bit of floating voltage down here, or not floating voltage, floating amperage. That's normal because how these work, it uses a magnetic field, and we're near electricity, so it'll pick up some stray stuff. A little bit of amperage you're reading down there isn't anything to be concerned about on the AC side. So we will take this, open it up, clamp it around that wire. So now that wire is going through the middle, and we can leave that right there. If I go turn on the microwave, you will see this spike up because amperage will be going through that wire. Okay, I'm back. Microwave is running. You can see we have 13.8.9 amps going through it. The microwave will shut off here in just a couple seconds, and this would drop down to 0, just the way we started. So we can see how much power is going through that wire. The microwave is done, and it's dropping down. You can see, we're back to nothing. And what some people don't know is you can actually test amperage on the black wire for your hot side, or your white wire for the neutral side. So let's take our amp meter, remove it off of that black wire, we put it over here, we'd read the same thing once turn the microwave on. But I want to show you on a Klein meter how that one works. So we use a Klein to test on a white wire and use a microwave again. Okay, on our Klein meter, we need to get to amps AC. So A, squiggly line, we are ready for amps AC. So just like we ended with the Greenlee, let's put the clamp meter around that white wire for our neutral to our microwave circuit. Let me go turn it on. Okay, I'm back again. You can see we're reading pretty much the same as we're reading on the black wire, 13.4. And the microwave shuts off. It'll go back down to 0. Now it went back to 0 because there's no more work being done through this wire. So that is how you check AC amperage. Okay, let's check some DC amperage. This will work the same way as your AC amperage, except you'll make sure your meter is set to DC amperage. For this situation, I'm going to take apart a light switch so we can get to the wires in the back of it to see how many amps are going through that to the lights. Okay, our light switch is apart, and on the back of this is a very simple switch. We have power coming in and power going out. And the single wire going out is going to our lights. It's actually a white with a blue stripe wire over here. That's power coming in and power going out. So let's take our meter. We were on AC amperage. Need to go to DC amperage. Like I said, it doesn't matter on this one if we're at 400 or 600. So let's just go to 400. On DC amperage, make sure you are zeroed out in the bottom. Now if we take this, open it up, put it around that single orange wire, you can see we have 1.8, 1.9 amps flowing through it. If I come over here to the switch and turn it off, our amperage went away. Now when you're checking light switches or things like this, you do want to make sure you are testing on the wire that's going out to the circuit. If I was to test around the wire coming in, like right now our light switch is off, but I'm reading 2.4, turn the light switch on, it doesn't change, but that's reading to the other light coming into the circuit. If I go to the other wire coming in, this would be reading both the light switch I'm on plus the other lights in the circuit. You see we're at 3.3. Now, flip the light switch off, it'll go down. But it still has a reading because the light switch over here is going through it as well. So let's go to the Klein meter. Have a little nice hang-up spot back here with a coat rack. So Klein meter currently is set on amps AC, and how we know is we see the squiggly line here on the screen, and we're on A. So we need to get to the DC symbol, hit the orange select button, and now changed our setting. Now we need to zero this out, so we have 0 amps reading right now. Push and hold that orange button to zero it out. From there, we have 0 amps reading. This will work the exact same way as a Greenlee. So we go back around that last wire we were on. We are reading 0. If I turn on the light switch I'm connected to, we'll go to 1.6. Turn on the light switch next to it. We go to 3.5. Now I'm on that single orange wire, and I have 1.6 amps going out of it. If I turn off a light switch, it goes down to 0. And technically on these meters and a clamp meter, right between this dash and that dash, that's where the wire should be. But in the real world, when you're trying to connect around a wire like this, you're lucky if you can even get it around the wire because RV wiring is tight. But what you will see on this meter is where that little plus symbol is. That means this clamp meter can test polarity to tell you which way the power is flowing through this wire. It's not really a diagnostic step, but just so you know, if you see a positive or minus down here, it's not a big deal. I'll flip this around just to show you. Now we have a negative symbol down there. Don't worry about that when you're checking amps. As long as you see numbers coming through it, you know power is flowing through that wire. Now this video is a quick overview of using the basic functions on a multimeter. If you are looking for more in-depth information, advanced techniques, more troubleshooting, more examples of how to use a multimeter, I made a full comprehensive course going through all of those examples. You can find a link for that course in the description below. Now, let's get into testing continuity. Now we'll test some continuity, and for the rest of this, I'm only going to show you using a Klein meter. They both would work the same way. You would put your meter onto the continuity symbol. So we'll take our dial, looking for that white sideways Wi-Fi symbol right there. And on the screen, you will see OL. So that means we're in continuity mode. Also in the tech world, that's called out of luck. That means no connection between it. So if we were to test our meter now, if we touch the leads together, we will get a beep. You'll see a reading on the screen, but that's not really important for just continuity. So touch metal to metal. Solid beep, and you also saw on the screen, it got right down to 0. That means there was a nice solid connection between one and the other. Now let's test a fuse. This is a one style fuse you might see in an RV. It's a glass fuse. On each end of it is metal. So metal on the left, metal on the right. What we're going to do here is take our test lead. We're going to touch it to the metal on one side with one lead. Take the test lead, touch the metal on the other, and hold it tight with your fingers, and we should have a solid beep. So, it was a solid beep, and if you watch the screen, you saw it get right down to 0 again. It's 0.1, so pretty much 0. Now let's take another style fuse. This is a blade fuse. You can check continuity on this back end here by these little metal prongs. Same way you can check voltage when this fuse is being used. When you just have the fuse in your hand, it's easier to touch the metal prongs on the bottom. So we're going to take our test lead on the left, touch the metal prong on the left, and hold it tight with our fingers. Do the same on the right with the test lead and hold it tight. Now we have OL. That means the fuse is bad. Let's take a little closer look here. You can see right in the middle of the fuse, that wire is not connected. So sometimes you can do a visual inspection on a fuse. If you see that, that means this fuse is blowing. But sometimes you can't quite see it. Or if you're checking a wire for continuity, let's say you had a long wire and you want to see if there's a break in a connection. You would take a wire on one end and strip it down, touch the metal end of the wire on this lead, and then the metal end of the wire on this lead, and the wire is going all the way through the RV. And then you touch it, and if you get a beep just like this, that means the wire is connected. But if you touch that lead to the wire and you don't have a beep, you have OL, that means that wire has a break in it somewhere. So the other function, just like continuity, is resistance. So let's get into that. What resistance is testing how much work something can do. So this is typically like a heating element, a motor, or things like that. For this situation, I have a heating element out of an RV refrigerator. And how this works, when you apply power to this, this part here gets really, really hot. And if we look at the package over here, they have different ratings. This one's rated for 325 watts. They're not all the same for every refrigerator, so if you are changing them, make sure you get the right one for the right model. And how this works is there's two wires coming off of it, and if this is inside of an RV, you would have one wire going to the hot side coming out of the circuit board, and the other wire going to the neutral side out of the circuit board. And it would send power down through that, heat this up, and that's how it would work to operate the refrigerator. So on our meter, I'm not going to change any symbols here to start with, so I can show you a couple things. So we're going to take our leads, we're going to put them into the end here. You can see the metal. We'll take our lead, pop it into the center. That'll hold on to the metal. Take our other lead, do the same thing, and we're going to watch the reading on the screen. So we were right at 43 ohms. Now, we have the beep on there. You don't need to have the beep for testing for resistance. And sometimes when you're testing resistance, if you just leave it in a default setting, you won't get an actual reading, like say testing a free sensor for an air conditioner. You need to put that into actually ohms setting. So hit the select button. Now down here on the screen, you can see we're at auto mode, that M or the K with that ohm symbol after it. Now it's not going to beep when we put it in there, but we still get the reading. Now it'll pick up if you had a different type of resistance reading you needed. So this situation, this heating element picks up whether we are on continuity or ohms, but some situations you have to be on ohms. So good practice if you're testing for resistance or ohms to make sure you're in the ohms setting. So we have 42.9, just about 43. This heating element is good. So that is how you test resistance. Now as a bonus, let's go through a few frequently asked questions I've had off other multimeter videos. So question 1, does continuity always work to test a fuse? Not always. Usually does. If you pull a fuse out, you'll get continuity, but I have had sometimes in an RV, usually a furnace is a situation for this, that there's voltage to the furnace, then when the furnace starts up, it starts drawing power, puts load on this fuse, and the weak connection opens up, and you'll lose voltage and the furnace will not fire up. So always a true way to test a fuse is by testing voltage going through it. If you have 13.5 coming in, 13.5 going out, fuse is good. The next question is, how do I test for low volts? You would test for low volts the same way you test for any voltage. You put your leads in the area you're checking and you read what the screen says. If your voltage is low, you have low voltage. What low voltage is typically below 12 volts. But really, if your RV is plugged into shore power, your converter should be holding a voltage somewhere between 13.2 and 13.7 volts. If you're not plugged in, if you're in the 12.0 to 12.6 range is pretty normal. When you get lower than that, things don't work properly. The next question is, why do I have a reading on the screen when I go to DC amperage? I honestly don't know that answer. It's just one of those quirks to that client meter that I'm used to dealing with all the time. So every time I go to DC amperage, I just make sure it's zeroed out and then I can go to work. And another question, can I replace my test leads? I've worn it out, I've cut it, something like that. Yes, you actually see this test lead here. It's at the point it's worn out, the red coating's coming off of it. You can get just test leads that replace them for clients or other kits for test leads. So let me show you here. What it's going to give you is a set of test leads and 2 little alligator clips that go onto the end of it. And I also want to point out here, looking at new leads, you see that little cone piece on the end of it? Right there. They put those on there for checking like circuit boards and things like that. For doing RV work, this won't give you enough metal tip poking out of it. So you take those off, throw those in the garbage. Now you're ready to test doing RV work. And there's a whole bunch of variety of leads you can get. You can get some retractable test leads like this that you can clip on. This is a nice 30-foot set that I picked up so I can check inside, run wires out a window, check things on RVs. There's a few kits like this that have a whole variety of things like needle probes and alligator clips and little extensions and weird things like that that you don't need them all the time, but every once in a while you need things like that. So these little extra leads and kits, I'll link them in the description of this video, so that way you can find them if you want something like that. We're at the end of the video, and I hope by now you know how to use a multimeter a little bit better than you did before to help trace down issues inside of your RV to figure out what's broken. And if you want more information on RV repair and maintenance, you'll want to check out the RV education page on our website. That's where you'll find the links to everything RV educational that we do. And remember, if you want to see more examples of troubleshooting with your multimeter, you'll want to check out the comprehensive course. It's all linked below. Now have fun using your multimeter.